Welcome to the session. Myself, I'm Shravani, Assistant Professor from the Department of CSE, and in today's lecture, we are going to cover binary search under Unit 2, which is Divide and Conquer. And till now, we have seen what is meant by general method and what is meant by substitution method and master's theorem. So we have seen the divide and conquer strategy, how to apply and what is the recurrence relation and all we have seen till now, right? And also how to solve that recurrence relation by using two methods. One is substitution method and the other is master's method. And now we will cover the application part. So there are number of applications using divide and conquer which uses divide and conquer strategy. Now in that we will see the first application as part of our syllabus, which is binary search. Now in this binary search we have two words, binary and search. So now binary, the general meaning of binary is two. It represents two. Search is a process of finding an element whether it is present in the given list or not. So now we are going to discuss this application in today's lecture. Now in today I am going to cover what is meant by binary search, and we'll see the example and also we will see the analysis part of it. And coming to the objective, and today's objective is the students are able to understand the complete concept of binary search. And outcome, after learning this lecture, the students are able to apply this binary search procedure to find an element in a sorted list, Now, there is a prerequisite for this binary search application. That is, in order to apply binary search on a list, the list should be in sorted order. You have to remember this point, which is the list should be in sorted order. Now, coming to binary search, what is the procedure of binary search? So, the main goal of binary search is to find an element X in the given list which starts from AI to AJ and whose size is n, which means that the list consisting of n number of elements, they are starting from AI to AJ. Now, this problem we are depicting with the help of P. Okay, this problem we are depicting with the help of P, and this P is equal to n comma a comma and so on aj. Here n refers to the size of n refers to the size of array or the number of elements in the given array, and ai to aj refers to the number of ai to aj refers to the elements in the given list, and x refers to the key element which we are going to find out whether that is present in the given list or not. Now, we will see the smaller one, which is a smaller problem. So, when there is a smaller problem, according to Dnc strategy, we have to return the solution. So, let small of p is equal to true if n is equal to 1, which means that if there is a single element and that is our key element or x, then directly we will return the position of it. That is the first position. So, in the first position itself we found that element. So, simply return the position 1. Now, if that is not smaller problem, which means that the list is somewhat big. So, at that time we are supposed to apply Dnc strategy, right? So, here the main thing is we need to divide our list into two sub-problems, okay, according to mid position. So, the mid value will be calculated by taking the average of the starting index in the given list and ending index in the given list. That is, let us consider low is the starting index and high is the ending index. Then mid value will be found by taking mid is equal to low plus high by 2. So, initially we are going to find out the mid value in the range. Initially we are going to find out the mid position, and now we are going to compare. If x is equal to a of mid, then simply we will return the mid position. If x is less than a of mid, then we can conclude that the corresponding x can be present in the left sublist of your mid. So no need of checking all the elements. So now I'm taking the high value as mid minus 1. Now I'm keeping the low value as it is and I am making the low value as mid minus 1. So I will only check the left sublist to the mid position. That is, even I will exclude the mid, I will only check in the left sublist. Now if x is greater than a of mid, then I can conclude that the corresponding element is present in the right sublist of your mid. So right sublist means here I have to consider only I have to change the low position to mid plus 1, whereas the high remains same. So initially we are going to find the mid value by taking mid is equal to low plus high by 2. Now after that I am going to compare whether this x is equal to a of mid or not. So if this x is equal to a of mid, then immediately the problem gets solved and we are going to return the mid position. Now if x is if that case failed, then if this case is true, that is if x is less than key element, then the element is present in the left sublist. Whereas if this condition evaluates to true, if x is greater than k, then the element is present in the right sublist. Now if x is less than k, so then what I have to do? That is, here I need to check only from ai to a mid minus 1. Only this list I have to check. Now, if x is greater than a of k, if x is greater than k, so in that case I need to check from a mid plus 1 to aj. That is only the right sublist. No need of checking the left sublist. So which means that I am removing some occurrences. Okay, whereas in your linear search have to compare each and every element in the given list. Their number of comparisons are more, whereas here number of comparisons are getting decreased in each and every level. Now, so if you have seen here, this is a I starting index and j as a ending index, and now in between there will be mid. That mid we are going to find out by means of I plus j by 2 in each and every iteration. Now recursive binary search. So recursion means a function called by itself is called as recursion. Now we will see the implementation or the algorithm of binary search using recursion. So for this, the parameters are a, low, high and x. A stands for the list of elements, low stands for the starting index of your array, high stands for the ending index of your array, and x is the key element which we are going to find out now. So now the given array which is from low to high and the elements are in the increasing order. As I said, the prerequisite for binary search is the list should be in sorted order. And if low is equal to high, what it means? I have a single element in the given list. So simply I have to return the corresponding position, which is number 1, because it is in the first position itself. So first position I have to send. That is, if low is equal to high, which means that here again I am checking with condition. If x is equal to a of low, then simply return low. Otherwise, this same condition can also be written as if x is equal to a of high, then simply return high, which is nothing but return the position, high position. Otherwise, return 0. So this is a smaller problem, which is if I am having the single element. Now, otherwise, which means that if I am having more than one element. So I need to find out the mid position, that is mid is equal to low plus high by 2, and then if x is equal to a of mid, if x is equal to a of mid, then simply return the mid position. Now else if x is less than a of mid, x is less than a of mid, then I need to call the same recursive binary search procedure by taking into the consideration called left sublist, which means that the low remains same and the high should be changed to mid minus 1. That's why I'm calling this recursive binary search with a, low, mid minus 1 and x. Now else. Else means here I have to call this recursive binary search procedure with a comma mid plus 1 comma high comma x, because here I need to take care about right sublist. So the low has to be changed to mid plus 1 and the high remains same. Now, okay, so here this is for smaller problem. If the given problem is small, which means that I have a single element. Now this is for if the given list has more than one element. So at that particular instance, I need to take care about all these things. So initially I need to find out the mid position. Now if x is equal to a of mid, simply return it. Else if x is less than a of mid, I have to call this recursive binary search with a comma low comma mid minus 1 comma x. Otherwise, I need to call this recursive binary search with a comma mid plus 1 comma high comma x. Now let's see the iterative procedure, which is by using either loops, while loop or for loop, whatever, right? So now we'll see that iterative binary search. So for this a comma n comma x, a stands for the elements and n stands for size of the array or size of the list, and x stands for the key element, which we are going to find out. Now here we are initializing the low value as 1 and the high value as n. Now while low less than or equal to high, what we are supposed to do? Here we need to find out the mid position, which is low plus high by 2. If a is less than mid, what it means? It is present in the left sublist. So yeah, when it is present in the left sublist, I need to make the high value as mid minus 1. Otherwise, I need to make the low value as mid plus 1. And if this case is no, I even fails, that is x greater than a of mid. So simply it is present in the mid position itself. So return the mid position. Now finally return 0. So this is the iterative binary search algorithm. Now let's see an example where I'm having the array size as 14 and these are my elements. Okay, index 0 consisting of minus 15, 1 consisting of minus 6 and so on, 13 index consisting of 151. Now let's see the first case, which is assume x is equal to 151, which means that here the key. Okay. Now let's see recursive binary search algorithm. So recursion means an algorithm called by itself is called as recursion, and this recursive binary search needs parameters a, low, high and x. A stands for the set of elements, which is list, and low stands for starting index and high stands for ending index of your list, and x is the key element which we are going to find out. Now here given an array a of low to high, which is globally declared, and the elements are in increasing order. As I said, the prerequisite for binary search is the list should be in sorted order, and x is the key element which we are going to find out. Now the smaller problem is if the list has only a single element or one element. So at that time I am checking with condition, which is if low is equal to high, then I am again checking with one more condition, that is if x is equal to a of low. If x is equal to a of low, what it means? It has only a single element. So at that time simply return the position. The position is low. Now, otherwise I can also write the same condition in another manner, that is if x is equal to a of I. If x is equal to a of I, simply return the high position. Okay, this is all for if the list consisting of a single element. Now, if this condition fails, then simply else return 0. Now, else. So, this else is come under if the list is having more than one element. If the list is having more than one element, simply I have to apply Dnc procedure. So, to apply that, I have to find out the mid position, which is low plus high by 2. Now, if x is equal to a of mid, so simply return the mid position. Otherwise, if x is less than a of mid, then I can conclude that the key element x is found in the left sublist. So, as it is found in the left sublist, the low remains same and the high changes to mid minus 1. Now, so for that, now if x is less than a of mid, then I am calling this recursive binary search algorithm with a comma, low comma, mid minus 1 comma, x. Now, else if x is greater than a of mid, so I can conclude that the x element is found in the right sublist. So when it is found in the right sublist, the high remains same and the low has to be shifted to mid plus 1. So I am calling this recursive binary search procedure with a comma, mid plus 1 comma, okay, high comma, x. Now, this is a closing of recursive binary search algorithm. Now let's see iterative approach. Okay, for iterative approach of binary search. So iterative means it uses while loop or for loop, whatever the loops we are having, right? So now given an array of 1 to n, which means that array size is n and x is the key element which we are going to find out. And initially the low value is initialized with 1 and the high value is initialized with n. Because here we have taken the starting index as 1 and the ending index as n. Now, while low less than or equal to high, we have to find out the mid position, that is mid is equal to low plus high by 2. Now, if x is less than a of mid, if x is less than a of mid, then simply high is equal to mid minus 1. Else if x is greater than a of mid, then low is equal to mid plus 1. Now, else return mid position. Now, let's see an example where n is equal to 14. Here the size of the array is 14. Here these are the list of elements. Now initially I will take a case which is key is equal to 151. So here I am searching for 151. So now what I am supposed to do? So here initially the low value is 0 and the high value is 13 and the mid value is 0 plus 13 by 2, which is equal to 6. Right? So now a of mid is equal to, now what is the a of mid value? So here which is a of 6, a of 6 is equal to 54. Is that 54 is equal to 151? No. So this condition failed. Now, is that 54 is less than, okay, is that 151 is less than 54? No. Even this condition is also failed. Now, is that 151 is greater than 54? Yes. This condition evaluates to true. So, as this condition evaluates to true, what I am supposed to do? Here, according to this condition, the element is present in the right sublist. So, I need to make the low to mid plus 1. Now, I have to make this low to mid plus 1. What is the mid position? 6. So, now this low has to be changed to 7. Now, high remains same. So, now mid value is again it will be changed to 7 plus 13 by 2, which is 20 by 2. So, which is 10 now. Now, again my next iteration will be started. So, now let us see. So, now the low value gets changed to 7 and high value changed to 13. High value remains same, which is 13, and the mid value is 10 now. Now, again we are going to check with a of 10. A of 10 value is 125. Is it 125 is equal to 151? No. So, now a of mid is equal to key. No. So, now is that 151 is less than 125? No. 151 is greater than 125? Yes. So, at that time again I have to make the low value to mid plus 1. Previously the mid value is 10. Now, I am making the low value to 11, high value is 13, and now my mid value becomes 12. Now, again a of 12. What is a of 12 value? 142. Is that 142 is equal to 151? No. Is that 151 is less than 142? No. 151 is greater than 142? Yes. So, now again I have to make the low value to mid plus 1. Now, the low value is 11 and now it is changed to, low value will be changed to 13. Now, low is 13, high is 13. So, it come under base case. So, now again as that low is equal to high, I need to take care about Okay, again the mid value is again 13. So now A of mid, what is the A of mid value? 151. So now 151 is equal to 151. As the condition evaluates to true, now simply I have to read that, I have to return the position of mid, which is 13. So I'll get a message called that 151 is found in the position called 13. So now if you have seen clearly here, therefore 151 is found at the 13th index. So this example is come under successful search. So now let's see another example. In the sense, this is okay, here we are taking the x value is 14. Now again the low value is 0, high value is 13 and the mid value is 6. Now again we are going to compare A of mid value is, A of 6 is 54. Is that 54 is equal to, now is that 54 is equal to the key element 14? No, condition failed. Now is that 14 is less than 54? Yes, condition evaluates to true. Now as this condition evaluates to true, I need to shift the high position to mid minus 1. So now the low value is 0 and high will be changed to mid minus 1, which is 5. Now the high is 5. Now again I have to find out the mid position, that is 0 plus 5 by 2, which is 5 by 2. So now mid value is 2. Mid value is 2. Now again A of mid, which is A of 2. A of 2 consisting of 0. Is that 0 is equal to 14? No. Again, is that 0 is, okay, is that 14 is less than 0? No. Is that 14 is greater than 0? Yes. So now at this point of time, I need to search for the right sublist. Right sublist means again I have to make the low to mid plus 1, which is now the low value will be changed to 2 plus 1, which is equal to 3. And the highest 5. Now mid value will be 3 plus 5 by 2. So now mid value will be 4. Now A of mid means A of 4. A of 4 is 9. Is that 9 is equal to 14? No. Is that 14 is less than 9? No. Is that 14 is greater than 9? Yes. 14 is greater than 9. So now what happened? Now the low, here as this condition evaluates to true, simply I need to make the low value to mid plus 1. So now the low value will be 5 and the high value is 5. So now I need to check for one more condition. As the low is equal to high, so I have to take for if A of low is 5, A of 5 consisting of 23, A of 5 consisting of 23. Is it 23 is equal to given x value? No. So the condition failed. So as this condition failed, I have to return 0. So whenever I am returning 0, the corresponding key element is not found. So here the x is equal to 14 is not found in the given list. That's why we are returning 0 finally, right? So now let's see this graphically. So now mid value is 6, A of 6 is equal to 54. Is it 54 is equal to given x 14? No. So likewise we are checking for all the conditions. Now low value changes to, okay, now low value is 0 and high changes to 5 and the mid value is 2. Now again we are applying the same procedure. Now again A of mid is equal to A of 2 is equal to 0, and again as the conditions are failing and as the last case evaluates to true, now as it is present in the right sublist, I have to make the low value to mid plus 1. Now low value is changed to 3, high value remains same 5 and mid value is 4. So likewise my procedure goes on. Okay, finally it will sense, okay, it will return a message called the corresponding element is not found. 14 is not found in the given list. Now let's see the analysis part of binary search. Now as I have discussed in the last class itself about Master's theorem, here the recurrence relation for this binary search is T of n is equal to T of n by 2 plus C. T of n is equal to T of n by 2 plus C. So here basically the list or the problem is being divided into two sub-problems according to mid position. That's why the recurrence relation came like this. T of n is equal to T of n by 2 plus C. So now when I am comparing this recurrence relation with the existed recurrence relation, which is AT of n by b plus f of n. So here A is equal to 1, B is equal to 2 and f of n is equal to C. So h of n is equal to, according to Master's theorem, h of n is equal to f of n by n to the power of log a to the base b. That is C by n to the power of log 1 to the base 0. So that can be written as C. Anything to the power of 0 is 1, right? So which is C. So that C into 1. So that 1 has to be rewritten as C into theta, C into theta of log n whole to the power of 0. So now this we will compare with this. So that is, then the corresponding u of n is theta of log n whole to the power of I plus 1 by I plus 1, which is theta of log n whole to the power of 1 by 1. So finally, this corresponding u of n will be theta of log n whole to the power of 1. Now, the T of n, that is the modified recurrence relation according to Master's theorem, is n to the power of log a to the base b into T of 1 plus u of n. Now, if I am substituting the corresponding u of n, I will be getting n to the power of 0 into theta of log n. So, out of that, the highest term is theta of log n. So, finally, the analysis, the time complexity for binary search is theta of log n. Now, there are three cases: best case, average case and worst case. Best case means the element can be found in the first position itself, or else if the list consisting of a single element, that single element is a key element, then it will be the best case. So, we will be having only one comparison. So, the best case is theta of 1. Average case. So, after some iterations, I found the element. So, that's come under average case. Worst case. Worst case means the element is found in the last position, or it might take more number of iterations, or the element might not be there in the given list. So, this is come under worst case. And this is all about successful search. Successful search means the element found. Whereas if there is an unsuccessful search means here the element is not found in the given list. So, for that the best case is best, average and worst case complexity. For all the complexity is theta of log n. For successful search it is theta of 1 and theta of log n. For average and worst case theta of log n. Whereas for unsuccessful search, for all the cases it is theta of log n. Now let's see one more GATE question. It is given in GATE 2018. So what is the worst case complexity for searching for a key in a sorted array using binary search? So here these are the corresponding options: big O of 1, big O of log n, big O of n log n and big O of n. So what might be the option? So here you need to read the question carefully. That is searching for a key in a sorted array using binary search. Generally, what is the prerequisite for binary search? The list should be in sorted order. So here the question is given directly. So what is the worst case complexity? What is the worst case complexity? Theta of log n. So that also can be read as big O of log n. So finally the option is big O of log n. So finally the answer is big O of log n. So now let's have our summary today. So we have seen what is meant by binary search, what is a problem statement, and also we have seen two algorithms: recursive implementation, iterative implementation, and also we have seen example, and also we have seen analysis part. And this is a small exercise. Take these two problems and try to find whether the elements are found in the given list or not using binary search. Thank you. Thanks for listening.